Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. Now see, Gate 2017 question. It is NAT type, numerical answer type question. So here you are not going to get any options. It is going to take some digit as the answer. So you will get keyword from there. You have to choose the answer. Means like filling the blanks you have to like this. Okay. So it is saying that the minimum possible number of states of a deterministic finite automaton that accepts the regular language this. So they are asking the minimum possible number of states of a deterministic finite automaton. So what is going to be the minimum possible number of states of a deterministic finite automaton for this regular language? And this regular language, what it is saying, you know that if we can give a DFA for a language, then it is a regular language. If we can give a FA for any language, then it is a regular language. So since that's why it is saying that it is a regular language. So already they are saying it is a regular language, so you can give a DFA. Now they are asking what is going to be the minimum number of states in the DFA. Means for this you need to construct a minimal DFA. Then you have to say that number of states is required for this language. Now this language is saying that first it will have W1, then A, then W2. And here W1, W2 belongs to AB star, means W1, W2 can have any combination of A comma B. And restriction is that length of W1 is equal to 2 and length of W2 is greater than equal to 3. Okay. So here we are having two restrictions, that length of W1 should be equal to 2 and length of W2 should be greater than equal to 3. Okay. Now since W1 is equal to 2, so it is going to contain W1 will be either A, AB, BA, BB, because no other strings we can get in place of W1 because its length should be 2, and we can take any combination of AB because W1, W2 belongs to AB star. Okay, any combination of AB. After that you will get A. So these are the kind of string that belongs to this language. After that it should have A. But if it will having B, then you have to go to date state because this kind of AAB not belongs to this language. Why? Because after W1 it should have A. Here it is having B. So you have to reject that. Okay. So now after W1A you need W2. Now W2 restriction is it should greater than equal to 3. Like A or A. BAB, any combination like this. These are the kind of string that belongs to this language. Now for this we need to construct a minimal DFA. Then we need to say what is going to be the minimum number of states. So now see the minimal DFA for this language. So first W1 length equal to 2. So this is saying length 0. This is saying length 1. Then again by getting any combination of AB, length 2. So W1 we got length 2. Then after that it should have A. So I'm going to Q3. But if we getting Q3B, then you have to reject it, date state. Because after W1 it should have A, it should not have B. So after it's in that date state, if you are getting anything, you will be there only. Okay. And you know that here sigma is AB. Sigma is your AB, so for every state you have to give transaction for every input alphabet. Now you reach W3. Now for this you reach Q3. So for this it is done. Now you will get W2. So W2 should be greater than equal to 3. Now after that you need to take a string whose length should be greater than equal to 3. Now AB length 1. Now again AB length 2. Again AB. Now length 3, accepted. Okay, final step. Now after that if you are again getting anything, you will be there only. Now it is greater than equal to 3. See, this we have did for till W1 because length should be equal to 2. Then we should require A, we got. Now for W2, length should be greater than equal to 3. Length 1, length 2, length 3. After that any combination accepted. Now see how many states we are having? 1, 2, 3, 4, 5, 6, 7, 8. So for this question we require 8 states. So you